So let's find the equation of this ellipse here, which has foci at negative 2, 0, and 2, 0, and whose major axis length is 10. So I usually draw a picture. Since I know that my foci are on the x-axis, that tells me about the orientation of the ellipse and also that there's no shift, meaning it's got to be centered at the origin. So my ellipse must be looking like this. Now the major axis length is 10. That's another way of saying that the distance between the vertices is 10. And by symmetry, that tells us that this must be 5, meaning this must be the point 50, and this must be the point negative 50. And so that tells me that A is 5. A, again, is we call that the semi-major axis. That must be a 5. The other thing is, because the semi-major axis is horizontal, we know that this ellipse is going to have the semi-major axis squared, or the a squared, below the x term, the x squared term. So we know that's a 25 right now. Now, in order to find the b value, or the b squared value, which goes below the y squared, in other words, in order to figure out what we should call this, I'm going to remind you of the Pythagorean identity we had. Now, if you forgot that, you could, so again, the Pythagorean identity was that just a squared equals b squared plus c squared in this case. If you ever forgot that, you'd have to draw this picture here to make an isosceles triangle, and this, conveniently, this is also 5, because because 2a will always be that constant sum. Remember that the definition of ellipse is that the constant sum between any point on the ellipse and the two foci, the constant sum of the distances is going to be 2a, so which means that that's a 5 and that's a 5. And now we know, since this is 2, then the Pythagorean theorem tells us that b squared must be 21. So a squared equals b squared plus c squared is worth remembering. At the very least, remember that that constant sum is 2a, so that you could rederive it with that picture if you had to. So there's the equation of our ellipse. Let's find the center, vertices, and foci of this ellipse and then graph it. Now we can tell right off the bat that there's a shift that's occurring in this ellipse. Now the first thing I identify with a shift is the center, because that's easiest to see. So the center is now, and the normal ellipses that we were deriving, which were centered at the origin, had center 0, 0. So this will have center negative 1, 2. So we'll plot that. We also note that 25 is a squared and 16 is b squared. Remember, a squared is always going to be the bigger of the two, which means that a must be 5 and b must be 4. And those tell me the distances essentially from the foci, from the center of the ellipse in either direction that I should move to get to those vertices and covertices. So I'm going to actually use blue to draw the ellipse. So if we start at the center and go, now again, the 25 is under the x squared, the x plus 1 squared term, so that's going to be horizontal movement. So I'm going to move to the right 5 and to the left 5. And then I'm going to move up 4 and down 4. And now I've got enough to sketch at least a decent ellipse. And I can get the coordinates for my vertices. I can just read them off. So my vertices would be at 1, 2, looks like 4, 2. Again, this is a vertice and this is a vertice. And also at negative 6, comma 2. Okay, we have to find, so we've gotten what so far? We got the center, we got the vertices, we've graphed it, we actually just need to find the foci. And to find the foci, let's go back to that identity we know. We know that a squared equals b squared plus c squared. And a squared is 25, b squared is 16, which means that c squared must be 9, which implies that c equals plus or minus 3. So be careful here. That's going to tell us the distance from the center we should move on the major axis. So I'm going to move 3 to the right. So there's one of my foci. I'll call that foci 2, I guess. And I'll move 3 to the left. Call that foci 1, or focus 1. I guess I shouldn't pluralize it if it's just one of them. So 2, 2 is one focus, and the other focus is at negative 4, 2. Okay, so again, I think if you find the center first, and then determine which orientation is gonna give you the major axis. From there, everything is pretty straightforward. I would just want to point out again that this Pythagorean identity is useful and important to memorize, unless again you want to just keep rederiving it with the isosceles triangle I described in the last slide.